This plastic bag is made of polymers. We use polymers every day. In fact, 5 trillion of these are produced each year, polluting an estimated 88% of our ocean surface. But what is polythene? And why do we find it so hard to stop using it? Polythene is a polymer. To understand polymers, imagine you're a jeweler making necklaces. Instead of stringing together individual beads, which stand for atoms in our analogy, you want to make this necklace with groups of beads, or molecules. For our lovely polythene necklace, each group of beads is exactly the same. These groups of beads are called monomers. This monomer, which is a grouping of 2 carbons and 4 hydrogen atoms, is called ethene. It's the most common monomer used in the production of petrochemical plastics. Ethene is part of the alkene family, which shares a couple important family traits. Every member of the alkene family has 2 hydrogens for every carbon. One of those traits is the general formula, and every alkene family member has 1 carbon double bond. When the jeweler strings these beads together into a long chain, she's essentially polymerizing. Polymerization is the creation of long chains of monomers. In addition reaction, the alkene double bond splits, forming a new connection with the carbon of the next monomer in line. Polymerization turns monomers into even stronger compounds. This is what gives polythene its useful characteristics. It's non-reactive with water, acid, heat, light. It makes food last longer. Still fresh after 2 days in my locker. It doesn't conduct electricity or heat. It can be used to insulate wires. It's resistant and durable, so it can be used in very thin layers to make it lightweight. It's also relatively non-flammable. And it's impermeable. This makes polythene hard to replace. Take its lightweight. 1 truck full of plastic bags carries more units in it than 7 trucks of paper bags. Take its impermeability. Cucumbers can last 14 days longer if wrapped in plastic, but polythene is tough to break down. It takes an estimated 500 years to degrade, overflowing landfills and contaminating oceans. But not all polymers have this problem with being hard to degrade. We are made of polymers. Our skin, hair, nail, bones, and muscles are mostly polymers, made from macromolecules called proteins, which your body makes from amino acids. My fingernail is made of keratin, a polymer. Our bones are made of collagen, also a polymer. This cotton t-shirt is also made up of a polymer called cellulose, which we get from plants. These biopolymers are very effective and biodegradable. Organic chemistry is all about how carbon compounds are formed and used. Some organic chemists study compounds like polythene to create better biopolymers, getting us what we need without harming the environment. Organic chemistry is vitally important. Who knows, maybe you will find a way to make better biopolymers and save us from a sea of plastic.